Notice the squeaking is back. How could you miss it? I'm so excited about it. All right. So 15 is what Victoria is asking about. It says we want to find the negative root or use Newton's method to approximate the indicated root of the equation correct to 6 decimal places. So we want the negative root of e to the x equals 4 minus x squared. So the first thing I would do is I would rearrange this so that it's equal to 0. So this guy is going to be like my f of x. Okay with that? And then I'm going to think for a moment. E to the x is always a positive quantity. So x squared minus 4 equal to 0. Whatever that x is has to be between negative 2 and positive 2, correct? So my guess, I think I'll pick as a negative number in between negative 2 and 0. Maybe try negative 1. I think is a feasible first guess. And then to calculate x2, then we're going to take x1 minus f of x1 divided by f prime of x1. But I'm just going to do that all in the calculator because, you know, why would I not? So type in my f of x. So I have e to the x plus x squared minus 4. That looks okay to me. I'll pick negative 1 as my guess. And then I'm just going to go back up and recover the setup that I had already on my calculator, so I don't have to go through all the buttons again to do that. And go ahead and press enter, 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 enter. So at this point, let's see, it looks like I have 1, 2, 3, 4, 5 decimal places correct. One more time. There we go. I got 6. So negative 2 might have been a better guess to start, but that's okay. Negative 1 got us there. Does that feel okay, Victoria?
Yeah, I just don't know how to guess negative 1. I guess like
0. And that probably would, did that not work out?
No, kept changing.
Okay. So what I recognized here was that this piece, I looked at these two pieces separately. E to the x is always positive, no matter what the x is. So for this thing to be equal to 0, this piece then needs to be negative. So I know that that's only going to happen on x's between negative 2 and positive 2, because any bigger than that or smaller than that, when I square it, I'm going to get a number bigger than 4. So I just wanted to pick something that was going to at least give me a negative quantity. And because it was looking for the negative root, I know that I went to pick the negative number, so something between negative 2 and 0. And I think probably anything you picked in there probably would have been okay, or you picked negative 2, or if you picked like negative a half or whatever. I think probably all would have worked out. 0 is probably a bad choice, because if you're looking for a negative root, our guess should probably at least be a negative number, right? Is that okay? No problem. Mia, do you have one? 4.7, number 15. Sure. And I will apologize in advance. Somebody asked about one of these optimization ones from 6th hour. I think it was like number 29 or something. And it just was like, just the solving piece was just terrible. And I apologize for assigning it. But like the algebra piece for the solving was just like so gross and unnecessary. So it's like 29 or 31 or something kind of in that neck of the woods. So I'm going to apologize in advance. Okay. It says we need 1,200 cubic or square centimeters of material available to build a box with a square base and an open top. So find the largest possible volume of the box. So, you know, like if we draw a little picture, you know, that's my picture, but, you know, like the top here is not there, right? So I think length, width, height are the dimensions here. We're maximizing volume. So one thing I know is that the box has, the base of the box is a square, so length and width are actually equal. So I'm just going to call those x's. So my volume is x squared h. Now what's the problem with this? I have two variables, right? I have the x and the h in there. So I'm going to try to find a way to rewrite h in terms of x. The way I'm going to do that is using the 1,200, which we haven't addressed yet. That 1,200 is giving me the surface area. So I'm going to write the surface area equation here. So I have the square at the bottom, and then I have 4 rectangles. Each of those rectangles has base of x and height of h. Let me stick a 4 there. Everybody's cool with that? So when I plug in the 1,200 for my surface area, I can now get the h by itself. So I'll subtract the x squared and then divide by the 4x. So that's my h. So my volume, oh, is it going to stop? It's teasing us. My volume then in terms of x is that. It's probably my projector. Before we go on, we should talk about the domain now for this function. So x is a length, so clearly x has to be at least 0, right? Can't have a negative value for x. That wouldn't make any sense. And a maximum value would be the square root of 120 or 1,200. Why? Yeah, any bigger than that, and I'm going to have a negative number as my volume, which I know is impossible also. I don't think it'll really matter. I just make them all or equal to's. Is that fair? The way I look at this, if I plug 0 in, well, I guess 0 should probably be a strict less than, because if I have a 0 in there, the denominator is 0, which is a problem. But if 12, or if it's actually the square root of 1200, the volume is just 0. And I think the 0 volume is okay. There's nothing, like algebraically wrong with that. Everybody cool? Okay. Now it's time to take the derivative. I look at this and I'm like, oh, there's a product and quotient rule. Yuck. I'm going to do some algebra and just turn this into a polynomial because, I don't want to hassle through all that calculus. So if I distribute the x squared through, and I'll rewrite these with common denominators as two separate fractions, I can then reduce each of those fractions. So that's going to be 300x minus x cubed over 4. Does that feel okay, guys? And I'd much rather do the derivative of this thing because that is a piece of cake. That's I can do that in my head problem. Yes. Yes. Silence is golden, guys. All right. I notice this derivative is a polynomial. So if I'm looking for critical values, there's no places where the derivative will fail to exist, which is great. So all I need to do is then set my derivative equal to 0. Oh, no. What a tease. So I'll subtract 300. And then I'll multiply by negative 4/3. And then I'll square root both sides. So that gives me plus or minus 20. I'm going to discard the minus 20 because it's outside of the domain of my function. So my test then is I'm going to do v of 0, v of 20, and v of the square root of 1200. I know that's 0. I know that's undefined. When I plug the square root of 20 in, again, I'm plugging in here. I guess I probably have to do that, huh? Yes. No. Actually, why would I plug in here, right? That's a dumb place to plug in. Plug in here, Kulik. Right? I just like less crap to type in. I guess conceivably I could have done that in my head, but just not, I don't think I'm interested this early in the morning. So I get 4,000 there. And I think those are centimeters, since the surface area was given to me in a centimeter. And let me just go check the answer key and make sure there wasn't anything that I missed, but I think that does it. Oh, sure. Yeah. Okay. So this piece here makes a difference. What did I do down here? I did this problem as if this was a closed interval. It's not. That's open interval, so I can't use this reasoning. Now I can still use this. This is still going to be the answer, but I have to show why this is maximum. So one way I could do this is I could use the first derivative test, and just do like something like that and show that this goes from positive to negative, and that would do. Or I could do a second derivative test, which is probably what I would do in this case, because it'll be really easy. So when I take the second derivative, I just get negative 3 over 2x. I just took the derivative of this, right? And I notice that this is always negative. So the second derivative test says if v of x is positive, or I'm sorry, it's v prime of x is equal to 0 and v double prime of x is negative, then x is a maximum. Either one, though, is you're doing the same thing. They both accomplish the same thing. Whether you do this or you look at the second derivative, they're both accomplishing the same thing. And the reason I had to do this instead of just plugging in the endpoints to my domain is that I had an open interval on my domain, not a closed interval. Does that feel okay, Mia? When it's not or equal to. Well, that's how I knew it was not, that 0 wasn't in the domain, right? Because it was undefined at 0. Does that feel okay? All right. Good. You guys probably have time for one more or so, Mackenzie? Same section, number 19? Sure. These ones take a little bit of work, right? All right. Okay. So here it says find the point on the line, 2x plus 3, that is closest to the origin. So let's just kind of sketch a picture. So there's the point at the origin. So there's my line. Everybody's okay with that? So I'm going to find some point on, or my goal here is to find some point on this line. We'll call it P, such that, I'll call that O, such that that distance PO is minimum, right? That distance I can calculate using the distance formula. So this is just going to be x minus 0 squared plus y minus 0 squared. Now, what's the problem with what I've written here? I have two variables, right? I have x and I have y. How do I rewrite this so that it's in terms of either x or y? In just one variable. Yeah, I just use this, right? So this point here could be x comma 2x plus 3, because that's what y is equal to. Everybody happy there? And now I could call this a function in terms of x, right? This is a d of x. And what's my domain for this function? Yeah, very good. Right, no matter what x I plug in, a distance is going to come out of it, right? So that's fine. my function y equals 2x plus 3 is defined for all x's, so I can pick any x on there, and it'll generate some distance to the origin. So this one is one where, again, we're going to have to use either the first derivative or second derivative test. Now, it's time to differentiate, but before I do that, I'm going to make the following observation to make my life easier. I'm going to make the following observation, that d of x is going to be minimum, where d of x squared is also minimum. Now think about that. If you have a positive number, because it's a distance, and you find the smallest positive number, and then you take that function and square it, if you square the smallest thing, it's still going to be the smallest thing, provided that the smallest number was a positive number, right? Everybody agree with that? So I'm going to do that. Why is that helpful to me? Yeah, it just makes the derivative like massively easier to deal with.
So can we do that on like any problem?
Involving a distance. Yeah, the distance is the key here, because I know that the minimum value must be a positive number. If the minimum value could be negative, you could not do this same trick, right? Because if you square a negative, now it becomes positive and it's no longer guaranteed to still be the minimum. You know what I mean? Yeah. So all these distances are positive. That's what allows us to do this trick. Okay. So when I take the derivative, I get 2x plus 2 times 2x plus 3 times the derivative of the inside, which is 2. So I'll set that equal to 0. Well, I'll observe that obviously this derivative isn't undefined anywhere because it's a polynomial, right? So I don't have to worry about any critical values other than where the derivative is equal to 0. So let's see, what do I got here? I got 2x plus 4, 8x, that's 10x plus 12. So I subtract 12 over and divide by 10. Well, that'll reduce down to negative 6/5. If I look at my picture, that seems rather plausible, right? I'd expect a negative value to be the closest. So I like that output right there. So to guarantee that this is a minimum, I'm going to look at the second derivative. Or you could do a first derivative test and check a value on either side of it. That would be okay also. But this derivative is so easy. I see the second derivative is always positive, which I know implies that this is my minimum. And I think it asked for the point. So to get the y coordinate then, I need to plug this in. So my answer is negative 6/5, comma 3/5. Now, if the second derivative was difficult to do, I would have used the first derivative test here. There's no reason I couldn't use that. I just looked at that first, or this first derivative was so simple that the second derivative was like, I can do that in my sleep. I will not screw that up. And it was just going to be less time consuming than like plugging values in. Not that those would have been all that time consuming either, but that's what I did. Does that feel okay, Mackenzie? Yeah, and this observation here was a big time saver, right? Noting that the minimum for the distance was going to be the same as the minimum for the distance squared. That saved us a lot of time because it made the derivative so much easier to deal with. And again, when you're dealing with a distance situation like this, you can use that trick. Okay. Let's finish up chapter 4 here, talking about antiderivatives. So we'll start with a couple of definitions. So we say a function f is called an antiderivative of f on the interval I if f prime of x equals f of x for all x in I. So example here, we're going to ask what is the antiderivative of x squared? What did I have to differentiate to get x squared back? So I need to find something that we differentiated to get to x squared. Everybody agree? Okay. So what kind of function is x squared? It's a polynomial, right? How do I differentiate a polynomial? I move the exponent to a coefficient and subtract 1 from the exponent, right? So I know immediately that the antiderivative is going to be x, is going to contain an x to the third in it, right? Now it's probably going to have some kind of coefficient also. Everybody agree with that? So when I do the derivative, I'm going to have 3 times x squared. Everybody agree with that? Let's call this g. If I compare f prime of x, which should be x squared, and g prime, which is 3x squared, what's the difference? The 3. So what should I be doing to this? What do I need to do to what should my original function have in order to get rid of that 3? Needs a divides by 3, right? So f of x here should be x cubed divided by 3. Everybody agree with that? Well, it's almost right. What's wrong with what I've done? Or I should say it's incomplete. What's the problem with what I've done? What if there was a 7 over here? When I take the derivative, what happens to the 7? Becomes 0, right? What if it was an 8 instead? Or 16? Or 56? Or negative 132? They're all going to 0 and disappearing, right? So this needs a plus c at the end to acknowledge that there could have been some extra constant hanging on to that just gets blown up and disappears when I do the derivative. It is not correct if you do not write the plus c. When we're asked to find the antiderivative and you're given no other information other than the derivative, then yes, they must have a plus c. We'll see instances here later on where we can actually figure out what the c is because we're given more information. But for right now, they do need to contain a plus c, which is what this next theorem is saying. So it says if f is the antiderivative of, if cap f is the antiderivative of little f on an interval I, then the most general antiderivative of f on I is cap f of x plus c, where c is an arbitrary constant. Okay? So let's do a couple of examples. So again, we're finding that most general antiderivative. What function gives me the derivative sine? Negative cosine. Yeah, very good. So the derivative of cosine is negative sine. But since we want the most general, what do I also need at the end of this? Plus c. Okay. What function's derivative is 1 over x? The natural log. So in this case, cap f should be, or the antiderivative of f should be, the natural log of x plus c. Everybody's good with that? Okay. Here, f of x is equal x to the n. So here it's not specific. So what did we do back here? What happened to the exponent? We added 1, okay? So this will be x to the n plus 1. And then we had to divide by that same n plus 1. And then, again, plus c. Does that feel okay, everybody? So again, the antiderivative rules are just your derivative rules running in reverse, basically, right? Is everybody okay with that? So it's not like new stuff being thrown at you. Here I've gone ahead and collected some of our common functions and what their antiderivative should be. Should be.
Are those some things we should memorize?
I think these are things you already have memorized, right? Like you know that the derivative of tangent is secant squared, right? You know that the derivative of sine is negative cosine, right? So it's just like, this is just taking all the things that you know already and just flipping them. Yeah. Does that feel okay? Okay. Let's take a look at this terrible, terrible looking thing. So this is my derivative. We're looking for all possible functions of g such that that is the derivative. What's that the same as asking for? The most general antiderivative. So it's asking for whatever my answer is, it needs to have a plus c at the end.
So when it says find all functions, does that mean
The most general antiderivative, yeah. So you have infinitely many functions because you could have plus 1 or plus 2 or plus 3 or plus 4. Put the plus c at the end, yeah. Okay. Before I start trying to do an antiderivative, what am I going to do? I'm going to simplify this part. Right? Because I don't want that to look like a quotient. I want it to look like a polynomial. because we don't know how to reverse out a product or quotient or chain situation. So I'm going to think about this as 2x to the fifth over x, which just becomes 2x to the fourth, and then the square root of x over x, which becomes x to the negative 1/2. Is everybody okay with what I've done to there? Okay. So let's do g of x. I know that the 4 coefficient doesn't matter when I'm doing the derivative. I just kind of ignore it and just tack it back on at the end. So I know that my antiderivative is still going to have that 4 there. And then what function, when I differentiate it, gives me sine? Cosine, right? So the antiderivative of sine would be cosine. 2x to the fourth, I'm going to use this antiderivative rule we came up within the previous example. What's up? The derivative of cosine. Oh, thank you. Yes. Thank you. So don't forget our negative. Very good. Thank you for paying such close attention. So the antiderivative of x to the fourth is going to be x to the 4 plus 1 over 4 plus 1. I'm just going to show a little bit of work there. Everybody good with that? So I just ignored the 2. And I'm going to do the same thing with the x to the negative 1/2. So if I clean this up then, okay. I have this. Oh, yeah, we would do very good. Mackenzie says, don't forget your plus C. Yes, paying attention. I love it. Attention to detail. Those are free points that you'd be giving away on the AP exam for getting those. Just free points on a free response. Guaranteed you would not get the mark if you forget your C. Or there's a mark for remembering your C at least. It's free points you're just giving away because you forgot. Yeah, what's up?
How did you get the 2 in front of the x?
So when I did the denominator, it's dividing by 1/2, right? So that's the same as multiplying by 2.
A negative 1/2 plus 1 is 1.
Yes.
Okay.
But it's in the denominator. So it's like dividing by 1/2. So I flip it up and it becomes a 2. Yep, exactly right. All right. Let's take a look at example 3 here. It says if f prime is equal to e to the x plus 20 times 1 plus x squared to the negative 1, and f of 0 is equal to negative 2. This piece right here is what I'm going to use in order to solve for C. Okay. Is everybody okay so far? And I'll show you how to use that to solve for C in a moment. All right, before I get going here, I'm going to rewrite this into a form that's a little bit more recognizable. Now, the way it was written originally, that looked like that was going to be like some kind of chain or quotient rule or something going on, right? But that, when I write it this way, that I recognize. What is that the derivative of? Tan inverse. Yeah. And what's the antiderivative of e to the x? This is the easy one. E to the x, right? Oops, that's not f prime, dum-dum. That's just f. That was f prime. So far, so good. Now let's solve for the c. So I know that f of 0 is equal to -2. So e to the 0 is 1. Tan inverse of 0 is, well, that's where x is 0, but y is 1, which is at pi over 2, right? That's where x is 0 and y is 1. Or, I'm sorry, it's y is 1 and x is 0. Because it's y over x. So that is at 0. Yep. So c is -3. All right. Find f if the second derivative of f is 12x squared plus 6x minus 4. And f of 0 is 4, and f of 1 is 1. Well, let's start by turning the second derivative into the first derivative. So x squared, the antiderivative is x cubed over 3. And the antiderivative of x is x squared over 2. And the antiderivative of 4 is 4x. Then I have my plus c at the end. So simplify that down a little bit. Everybody happy there? So at this point, I could plug in and solve for c. it shouldn't matter. Does it matter if I do this now? That sounds so bad now. I think it's literally going to like catch on fire or something.
Wait, it just like stopped.
Yeah, it's the fan. So like after it cools it, the fan just turns off and then stops making all this terrible racket. I just need to get another box fan hanging from the ceiling blowing in there so the other fan never has to turn on. All right. Well, let's wait. I'm not sure if that matters or not. So let's just wait and do it at the end where I know it's going to be okay. Yes, thank you. Thank you. Absolutely. Normal, regular unleaded F. So I have another constant. I just picked the next letter in the alphabet. So instead of, it's not the same C. So I could call it like C1 and C2. Or I could just use like D. Yeah, it's doing the same thing. Yep. Because I anti-differentiated again, I get another plus a constant at the end. Because the C is no longer a constant. It's a coefficient on a variable now. So what do we have here then? Simplify things down. That's going to be x to the fourth plus x to the third minus, what do we have? 2x squared plus cx plus d. Okay. So if I do f of 0 is equal to 4, that's going to give me 0 to the fourth plus 0 to the third minus 2 times 0 squared plus c times 0 plus d, which should equal 4. So it tells me d is 4. Everybody's okay with that? And if I do now f of 1, I'd have 1 to the fourth plus 1 to the third minus 2 times 1 squared plus c times 1 plus 4 is equal to 1. So let's see, I have 1, 2, minus 2 is 0, plus 4, so I subtract the 4 over, so c is negative 3. So that's everything we need. Everybody good with that? And to answer my question, like, could I have plugged in to find C right here? Well, no, because I don't know anything about f prime, right? I only knew about f of x. So I had to wait until I anti-differentiated twice before I could plug in. You remember when I paused and was like, can I find C right now? No, dum-dum, you don't know anything about f prime. There's nothing to plug in for f prime. Oh yeah, that's an excellent point. All right. I got 2 more story problem examples, and then we're done, Zos. You guys happy? I mean, again, this is not too bad, right? Could be worse, exactly. Yeah. All right. Here it says that a particle moves in a straight line and has acceleration given by a of t equals 6t plus 4. Its initial velocity is v of 0 equals negative 6. And its initial displacement is s of 0 equals 9. Find its position function s of t. So this is the key, is that acceleration is the second derivative of position. Velocity is the first derivative of position, or it's the, or you could say that acceleration is also like the first derivative of velocity. Right? Those are the key relationships. Yep, or the second derivative of position. So that's all we're going to be doing. We're just going to be doing anti-differentiation to get back to the previous. So one step back from acceleration is velocity. So I'll do my anti-differentiation. So t to the first becomes t to the 1 plus 1 divided by 1 plus 1. 4 just gets a t tacked on the end, and then I have a plus c. To solve for that c, I'm going to do v of 0. Which tells me that c is negative 6. So my v of t is going to be 3t squared plus 4t minus 6. So far, so good. Now I can anti-differentiate that. It's going to be t to the 2 plus 1 divided by 2 plus 1 plus 4 times t to the 1 plus 1 divided by 1 plus 1 minus 6 to the t plus c. And I know that s of 0 is going to be just 0 to the third plus 2 times 0 squared minus 6 times 0 plus c equal to 9. So that tells me, well, maybe let's use d here. That's confusing. We have two different c's. It tells me that d is 9. So my final answer is t to the third plus 2t squared minus 6t plus 9. That's my position function. Did that go okay?
Yeah. Can you scroll back up a little bit?
Yeah, of course, dude.
Okay. So why it's in oh never mind. Okay.
We're okay?
Yep.
Okay. All right. Example 7. A ball is thrown upward with a speed of 48 feet per second from the edge of a cliff 432 feet above the ground. Find its height above the ground t seconds later. When does it reach its maximum height, and when will it hit the ground? So what are we given here? What is this? A ball thrown upward with a speed of 48 feet per second. That's my equation for V of t. Oh, no. That's V0. Excuse me. Okay. What is the edge of the cliff 432 feet above the ground? What is that giving me? That's S0, our initial position. And then if we're asking for the height above the ground, t seconds later, what are we asking for there? The function s of t. Is everybody okay with this? Okay. Physics students in the class, what can we infer from this situation? What do you know about falling objects? Yeah, well, that's meters per second, right? What do you remember what it is in feet per second, since everything else was given to us in feet? It's negative 32 is the number we typically use. Now, there's decimals involved there, but that's acceleration in feet.
So acceleration in calc is negative 32.
Is what?
Acceleration is in calculus.
Well, if it's just the unit, it's because we're in feet, not meters. If the question was in meters, then you can use negative 10 or negative 9.8 or whatever your fancy is. When I took physics, they made us use negative 9.81. Yeah, they wanted that much accuracy on there. Anyways, so we're going to go ahead and anti-differentiate. I'm going to solve for t. Or solve for c, excuse me. So I know c is just 48. Notice here, I should point out that because it's upward, the velocity should be positive, and because gravity is acting downward, the acceleration should be negative. Everybody's cool with that? Okay. So we have our new velocity equation. So now let's anti-differentiate that. So negative 32 t to the 1 plus 1 plus 48 t plus d. S of 0 should be negative 16. 0 squared plus 48 times 0 plus d is equal to 432. Well, that just tells me d is 432. So my S of t should be negative 16t squared plus 48t plus 432. So that's the height above the ground t seconds later. I guess let's just do that. It then asks, when does it reach its maximum height? What do I need to do there? I need to set the velocity equal to 0, or find the critical values for velocity anyways. Now, velocity is a polynomial, so the only critical values is when velocity is equal to 0. And then 48 divided by 32 simplifies down to what, like 3 over 2, right? Everybody's good with that?
It's like a general question, but whenever you have 0 that you're plugging in, is the answer always going to be one of your givens? Like you only have one constant?
Well, it depends on what the function was. Like if there's an e to the x in there, e to the 0 is 1. So the fact that it was a polynomial, yes. If your function you're plugging the 0 into is a polynomial, then yes. But if there's trig stuff in there, or log stuff in there, or exponential stuff in there, then no is your answer. You know what I mean? So it just kind of depends. I know. Okay. And I know that this is a maximum. How do I know that the maximum occurs there? Yeah, because the second derivative is negative. Excellent. That's the second derivative test, right? I got it for free, easier than doing a first derivative test. You could do a first derivative test there. That would be okay. Pick a value on either side of t and plug it into the derivative and shows it goes from increasing to decreasing. That's okay. But like, I'd pass. So that answers the when question. And then it asks also, when does it hit the ground? What do we want there? Yeah, very good. When s of t is equal to 0. Um, 16 and 48 are both divisible by 16. I wonder what about 432? If it is, would be very nice. So it is. So I'm going to divide everything by negative 16. So that I see is now factorable. Is it? No, that's 3 times 9. Oh, okay. So now we'll quadratic formula it. So let's see. 4 times 27. Yeah. I guess it's 112, right? 10. Yeah, it's bad day. 108 plus 9 is 117. And then I can discard the negative, right? Because the when question is asking for a time. That has to be a positive number. So that'll be good.
That's the answer.
Yeah, you could turn it into a decimal if you wanted to. That would be fine as well. I just elected not to because you guys all have calculators. We good, everybody?
I have a question.
Sure thing.
So for the max height one, we know like it's like obviously like max because it's like second derivative was negative. So the second derivative is negative 32.
Yes.
And then the second.
Oh, everywhere.
Is 3 halves.
Is the what is 3/2?
The first derivative.
That's the, no, 3/2 is the critical value. Right?
And what is it that's negative and positive? Like we know that negative 32, that's negative.
So my functions, I have a of t equals negative 32. I have v of t is negative 32t plus 48. I have s of t equals blah, 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 blah. Right? So those are my acceleration, velocity, and position functions. So if I'm doing this, the second derivative test, what I want to know is where the derivative is equal to 0 and compare that with what is the second, or what is going on at the second derivative at that value. But I know the second derivative is negative everywhere. So it's certainly negative there, that's why it's telling me it's a max.
And the first derivative is at 0 to 48.
Yes. V of 0 is 48. Yes. That's exactly right. So I think that does it for me. So there's your problem set. Okay, we have what, like 10 minutes left or whatever? What can I do for you to help with your preparations? What can I do? What can I do to help?
Remember that like study thing, like the guide that you made last year?
The guide that I made last
You made
year.
like a study guide for your final last year, I think. Not like a study guide, like a practice. Kind of like practice test, I think.
For trig and pre-calc? I think it was all previous test
Yeah,
questions.
it was all.
Can you post
Remember there was the
blank
sheet
test?
that we all just like.
Not like the first one.
Sure, I can post the
Just like practice problems. Like, or like how we did our test where you give us like ones to narrow. Yeah.
sure. Okay, so I can post a blank version of the previous tests. I can do that. That's easy to do. And then you want some targeted homework problems.
Yeah.
Okay.
What does study guide mean?
What? I'm sorry. There's just two people talking at once.
Can you post the answers for the test right now?
I probably can. I think I have to scan my sheets or whatever and hope that I still have them. They're probably in my desk somewhere. Sergio.
But like a study guide, like 100. I know it's really long. It would be a really long final. So a study guide, like with waiting for the last test, probably too much to ask.
I think for the most part, I tried to base the exam questions I wrote off of like reasonable homework stuff.
Okay, so it wasn't quite like test questions.
The test questions I wrote, or the ones that I gave you examples for the previous test, were things that like I found a previous like AP free response question that I kind of carved out the piece that we were doing, is why I kind of made some practice versions of those, because they weren't necessarily like anything you had seen in the homework. I didn't do that for the final. I just took, I used kind of a homework problem as a base.
Okay.
So I think that would probably be more helpful for you.
Okay. Yeah.
So I'll try to do that today. So if you guys check back in your OneNote towards the end of the day, I'll try to have something in there, or at least the start of something in there for you. Yeah, no problem. Again, I didn't have a chance to write anything. I was gone yesterday. So I wanted to get an idea of what you guys need and what I can do without. I know time is running out, right? Well, I guess you guys don't have the exam till next week. So you have all next week, which is nice. So on the 2 days that we meet next week, what do you guys want to do?
Just review. If you give us like the homework or if it's in by day, then I feel like we can.
Do you want me to pick out some specific problems and just like, hey, everybody try this for 10 minutes and let's go over it?
Yeah.
Okay. We'll do that at least the first day, and then you guys tell me if you want more of that afterwards or not. Okay? So I can do that. All right.